It's likely a gas giant almost as big as its nearest planetary neighbor, Neptune.
For years, scientists have suspected the existence of Planet 9, a massive, unseen world influencing the orbits of distant objects. But no telescope could find it until now.
It's a blank piece of sky.
So just nothing in here, just darkness.
Nothing at all. Complete darkness.
Thanks to a revolutionary quantum AI system, evidence has emerged, hidden in the vast data collected by the James Webb Space Telescope. This isn't just a random signal, it's a gravitational and infrared anomaly that perfectly fits predictions for Planet 9. A shadowy object, a strange pulsing signature, and a mystery that could rewrite everything we know about our cosmic neighborhood. In this video, we'll break down the discovery, the technology behind it, and what it means for the future of space exploration. Planet 9 may finally be real. The mystery at the edge of the solar system. For decades, astronomers have been captivated by strange patterns in the outer solar system, specifically the unusual orbits of distant Kuiper belt objects. These icy bodies, far beyond Neptune, appear to cluster in a way that defies current models of planetary motion. The most compelling explanation? The gravitational pull of a massive, unseen object influencing their paths. This has led to the tantalizing hypothesis of Planet 9, a mysterious world lurking in the darkness, far beyond the reach of conventional telescopes. The concept of an unknown planet is not new. Throughout history, discrepancies in planetary orbits have led to the discovery of new worlds. Neptune itself was predicted before it was observed. But Planet 9 is different. It's potentially 5 to 10 times the mass of Earth and could take 10,000 to 20,000 years to complete a single orbit around the Sun. Its immense distance and low reflectivity make it incredibly difficult to detect, even with the most advanced instruments. Up until recently, Planet 9 was thought to exist mainly through mathematical models and indirect observations. The most recent discovery in space-based infrared imaging, more precisely from the James Webb Space Telescope, has brought new paradigms into being. Yet the amount of data is staggering. This is precisely where quantum AI comes in. It utilizes advanced probabilistic modeling to examine data for anything anomalous, gravitational distortions, or very faint thermal signatures that might suggest the presence of a supermassive body in the shadows. What makes this mystery so fascinating is that it throws the very concept of how we understand the structure of our solar system into the limelight. If indeed Planet 9 exists, it would stand to not only become one of the members of our planetary family, but has the potential to change entire theories behind how planets form and evolve. And if it were to turn out to be something even more bizarre, such as a black hole or a remnant of some failed star, the very consequences of such an observation would extend from astrophysics to cosmology, leading us to reconsider what is really out there in the cosmic dark. It could challenge long-held assumptions about the stability and boundaries of our solar system. It might also offer new clues about the chaotic early days of planetary formation, when giant bodies were flung into distant orbits or lost entirely. Ultimately, confirming Planet 9's existence could open the door to a new era of discovery, pushing the frontier of space science far beyond what we currently imagine. To truly uncover what's lurking in the dark outskirts of our solar system, scientists turned to the one instrument powerful enough to see the unseen: the James Webb Space Telescope. Enter the James Webb Space Telescope. Launched in December 2021, the James Webb Space Telescope, JWST, is the most powerful space observatory ever built. Designed primarily to peer into the early universe, JWST also offers unprecedented capabilities for observing our own cosmic neighborhood. With its advanced infrared sensors, JWST can detect faint heat signatures from extremely distant or cold objects, perfect for spotting things like icy dwarf planets, rogue asteroids, or even a hidden giant like Planet 9. Unlike visible light telescopes, which rely on sunlight reflected off celestial bodies, JWST excels at capturing infrared radiation, the kind of light emitted by cold and distant objects that don't shine brightly. This makes it ideal for scanning the Kuiper Belt and beyond, where objects are incredibly dark and move slowly across the sky. With its wide field of view and deep sensitivity, JWST has been quietly collecting massive volumes of data on the solar system's edge. The problem, though, is not with the challenge, but with the data itself. JWST creates terabytes of intricate imaging that is riddled with noise, distortion, and thousands of imperceptible blips. Amidst all this disorganization may be the secrets to something remarkable. Conventional methods of processing data can miss faint patterns, and hence scientists resorted to quantum AI, a potent tool that could study probability fields and gravity trends over vast distances with startling accuracy. With the synergy of JWST and quantum AI, scientists now possess the means to sort through this cosmic haystack with more precision than ever before. For the first time, they've been able to identify persistent anomalies, gravitational distortions, and weak thermal signals that are consistent with predictions for an unseen massive object. The telescope didn't merely take a picture, it took a breadcrumb trail of evidence, and that trail could lead straight to Planet 9. Each anomaly strengthens the case that something massive is lurking in the farthest reaches of our solar system. Researchers are now cross-referencing these findings with simulations to narrow down possible locations. If these clues hold up under deeper analysis, we could be standing at the brink of one of the most profound astronomical discoveries of the century: the quantum AI breakthrough. While telescopes like James Webb provide the raw data, it's the quantum AI system that has transformed the search for Planet 9. Traditional algorithms, even the most advanced classical ones, struggle with the sheer scale and complexity of deep space data. Quantum AI, however, operates on entirely different principles, leveraging quantum mechanics to process multiple possibilities at once, rather than linearly. This allows it to detect incredibly subtle patterns across vast regions of space that would be invisible to conventional methods. At the heart of this breakthrough is the AI's ability to work with probability fields and quantum entanglement, creating a dynamic model of gravitational interactions and infrared emissions across the solar system's edge. Instead of just enhancing telescope images, it maps how space itself is behaving, where light is bending unnaturally, or where the orbit of distant objects doesn't match expectations. These deviations, once considered noise, now serve as clues in the search for something massive and hidden. In just 72 hours, the system scanned terabytes of JWST data and identified a consistent, slow-moving signal, accompanied by a faint, persistent infrared signature. More than just an anomaly, this was a recurring pattern that aligned almost perfectly with theoretical models of Planet 9. The AI's final output included not just detection, but a 97.2% confidence rating, a staggering level of certainty for such a faint and distant target. This is more than a technological milestone. It's a new way of doing science. The fusion of quantum computing and astrophysics is rewriting the rules of exploration. For the first time, we're not just relying on what our eyes can see. We're using the power of quantum probability to predict, locate, and understand objects far beyond our observational limits. And when it comes to Planet 9, it could be the answer to finally uncovering one of astronomy's most enigmatic secrets. If confirmed, this discovery would not just add a new planet to our solar system, it would force a complete rethinking of its formation history. Questions about where Planet 9 came from, how it survived the chaotic early solar system, and what it's made of would become urgent priorities for future missions. In many ways, finding Planet 9 could be like finding a lost chapter in the story of our cosmic origins. Detecting anomalies in the data, the breakthrough came not from a single dramatic image, but from a pattern buried in noise, a subtle series of irregularities spread across vast datasets. As the quantum AI combed through James Webb's deep field scans, it began to highlight specific areas where the gravitational behavior of objects didn't align with any known celestial body. These weren't one-off glitches. They were consistent distortions, minute gravitational tugs and slight shifts in infrared light that repeated across different datasets. One of the key anomalies was a slow-moving signal, traced over time, that indicated the presence of a massive, dark object subtly pulling on surrounding bodies. Unlike stars or known planets, this object emitted no visible light. What made it stand out was a persistent, low-level infrared glow coming from an otherwise empty patch of sky. It was faint, cold, and consistent, exactly what astronomers would expect from something like Planet 9. The AI also found orbital anomalies in trans-Neptunian objects, bodies well beyond Pluto, whose movement couldn't be accounted for by the solar system's known gravitational forces. The distortions weren't random. They indicated a particular area where an unseen mass was pulling through a long-range gravitational force. This type of information, impossible to decipher by hand, became a puzzle the AI could finally solve. When the system picked up on these results, scientists were amazed. This wasn't just a statistical anomaly. It was a convergence of independent indications: gravitational inconsistencies, thermal readings, and orbital perturbations, all pointing in the same direction. For the very first time, researchers had an empirical map of where Planet 9 could potentially be lurking, one based not on supposition, but on an intelligible, measurable pattern in the fabric of space. It's a cosmic breadcrumb trail that no human eye could have spotted without help. Every clue stitched together forms a bigger, clearer picture, one that hints at an unseen giant shaping the outer solar system from the shadows. The next steps are clear: focus observational power, gather more direct evidence, and prepare for what could be one of the biggest planetary discoveries of the century. Planet or something else? Competing theories. The evidence gathered so far is compelling, but what exactly is this mysterious object hiding in the outer reaches of our solar system? Scientists are divided between two primary theories. Theory A suggests that this is indeed Planet 9, a massive, cold planet, possibly a gas or ice giant, between 5 and 10 times the mass of Earth. Its orbit would be highly elliptical, taking tens of thousands of years to circle the Sun, which explains why it has remained hidden for so long. This theory lines up with early predictions made in 2016, when astronomers noticed a clustering of trans-Neptunian objects moving in strangely aligned orbits. The gravitational pull required to keep them in such formations pointed toward a large, unseen planet. Now, with infrared signals and gravitational anomalies detected by quantum AI, this once speculative idea has gained new credibility, perhaps even validation. Not all scientists are so sure it's a planet, however. Theory B suggests an entirely stranger explanation: that the object might be an ancient black hole, a tiny but extremely dense remnant of the early universe. Even though the object would only be a few centimeters wide, such an object might exert the same gravitational pull as a giant planet. This concept, if more radical in nature, has support based upon the novel infrared signature picked up, one which defies known planet but could signpost an exotic and non-illuminous nature. Both theories have far-reaching implications. If it's a planet, we might have to rethink our comprehension of solar system formation and its outer structure. But if it's a black hole, we're in a whole other universe of a discovery, one that implicates dark matter, cosmology, and the birth of the universe. Either way, what's hiding out there is not just another rock in space. It's a cosmic wildcard, and we're just beginning to understand what it means. Future missions, equipped with even more advanced instruments, are already being proposed to investigate these possibilities directly. Whether it's a giant planet or a primordial black hole, the stakes couldn't be higher for our understanding of the cosmos. One thing is certain: whatever we find will permanently alter humanity's map of the solar system, and maybe even our place within it. But just as theories began to take shape, the object's behavior introduced new layers of mystery. revealing unexpected motion and strange signatures that defy simple explanation. Unexpected signatures and irregular motion. As the quantum AI continued analyzing the object, it uncovered something scientists didn't expect. The object's gravitational influence didn't behave in a perfectly smooth, predictable way. Instead, it wobbled. Subtle irregularities in its motion suggested that its gravitational field was being influenced by something else, perhaps a small orbiting companion, a ring system, or even a surrounding cloud of debris. These findings complicate the object's profile and hint that there's much more going on than initially thought. Even more puzzling was a repeating pulse detected in the infrared data. The eye flagged a rhythmic thermal fluctuation, a narrow band of reflected heat that appeared to flash at regular intervals. While this could be the result of natural processes like rotation or tidal interactions, the regularity and precision of the pulse raised eyebrows. Some scientists cautiously suggested it might even hint at artificial interference, though such ideas remain highly speculative. If it does possess a moon, that might be the cause of the wobble. Two bodies exerting gravitational forces on each other would easily create a measurable deviation in motion. Or a ring system, such as Saturn's, might provide an asymmetrical mass distribution that warps the object's gravitational field. A debris halo surrounding it, or interaction with other undetected objects, might also be the culprit, complicating the dynamics of this secret world further. These atypical behaviors make us question the first assumption that this is simply a faraway, uncomplicated planet. Rather, they present the possibility that this is a more sophisticated and perhaps never-before-seen object. Each pulse, each wobble, and every anomaly is a clue, a data point that could lead us to rewrite the rules for what we define as a planet, or even make us confront the possibility that this is something outside our current classification schema. The deeper we look, the more it feels like this object is defying easy explanation, existing somewhere on the boundary between familiar celestial mechanics and the unknown. With every new observation, the mystery grows, not shrinks, beckoning scientists to push the limits of technology and imagination. Whatever it is, it's clear. We are on the edge of a discovery that could either expand the frontiers of planetary science or completely blow them apart. A glimpse into the exotic. As the data continues to pour in, one thing is becoming clear. This object might not fit neatly into any known category. While the theories of a hidden planet or a primordial black hole are already compelling, there's a growing sense among scientists that we may be looking at something far more exotic. The unusual infrared pulse, the gravitational irregularities, and the object's apparent resistance to clear classification all point toward a deeper mystery, perhaps even one with technological or artificial implications. Some speculative theories propose that the object could be a relic of ancient engineering, a massive structure built by an advanced civilization, long dormant and now barely detectable. While this idea is far from mainstream, the consistency of the pulsing signal and the object's unexpected thermal behavior have stirred conversations about potential techno-signatures, signals or phenomena that suggest the presence of intelligent design rather than natural processes. Another hypothesis building subtle momentum is that the object may be a fragment of an overall unseen system, perhaps even a residue from a collapsed stellar core or remnant of a dwarf star. Such an object might have been captured by our sun's gravity billions of years ago, sheltering in the far reaches of the solar system ever since. This would account not just for the strange gravitational signature, but also the weak heat radiations that fail to match ordinary planetary orbits and masses. Although these concepts might seem like science fiction, science is frequently advanced by pushing the limits of what we believe to be possible. The find at the border of our solar system is providing us with a glimpse into the unknown, a realm where astrophysics, cosmology, and imagination meet. Whether it's an odd new form of celestial object, a lost star remnant, or something completely new, the exoticism of this object requires us to redefine what's really out there in the black. Every new dataset edges us closer to a revolutionary discovery, blurring the line between the familiar and the extraordinary. It reminds us that the universe is not obligated to make sense according to our rules. It plays by its own. And perhaps just beyond the reach of our current understanding waits a secret that could alter humanity's place in the cosmos forever. The mere prospect of finding something so novel is already refashioning the questions that scientists are seeking to answer. No longer is the question limited to planet or black hole. It now also reaches across the domains of cosmic artifacts, interstellar debris, and the teasing hints of non-natural events. Every new chunk of incoming information is less about validating existing theories and more about getting ready for the shock of something completely beyond our conceptual frameworks, a genuine first contact, not with life itself, but with the deeper, stranger architectures of the universe. Captured rogue or dead star remnant. Among the more fascinating theories about this mysterious object is the idea that it didn't originate in our solar system at all. Some astronomers propose it could be a captured rogue planet, a wandering body ejected from another star system and later ensnared by the sun's gravitational pull. Rogue planets are believed to be common in the galaxy, drifting through interstellar space after being flung from their original systems. If this object is one of them, it would mean our solar system has absorbed a cosmic traveler, quietly orbiting on the outermost fringe for eons. This theory could explain several of the object's unusual traits. A captured rogue would likely have a highly elliptical orbit, a strange axial tilt, and unpredictable motion patterns, traits that align with what the quantum AI has detected. Its origin outside the solar system would also make it chemically and compositionally different from native planets, potentially contributing to the faint and unusual infrared signature picked up by JWST. Even more interesting is the notion that this object could be a remnant from a dead star, a collapsed core of a dwarf star or a failed brown dwarf, now cool and dark after millions of years. It could have slowly wandered into our solar system and been gravitationally captured by the sun. Although extremely uncommon, remnants would have intense gravitational fields, but release no or little light, in keeping with what's observed. That would put the object into a completely new category, not a planet, but a relic star. Either possibility would radically alter our perception of our solar system. If this is a rogue planet, or a stellar remnant, it implies that the sun's gravitational sphere of influence might reach much further and be much more active than we had thought. It introduces the possibility that our solar system is not an isolated system, but one that exchanges with, and perhaps incorporates, alien objects from the larger galaxy. This would provide a sensational new chapter in the history of how our solar system was created and developed. It would also suggest that planetary systems throughout the galaxy might be far less stable and more interconnected than previously assumed. Objects could migrate between stars, carrying with them clues to distant ancient events we have yet to understand. In essence, the discovery could turn our solar system from a closed, familiar neighborhood into a dynamic, evolving crossroads within the Milky Way. The implications for future studies would be immense. Researchers would have to work on new models to account for how gravitational capture occurrences occur and how often they occur throughout the galaxy. It would also allow for investigation of an object that was created under completely different stellar conditions, providing a once-in-a-lifetime opportunity to directly examine extraterrestrial planetary chemistry and structure without having to venture outside our own solar system. In a sense, this object might represent a natural time capsule. Beneath its surface, contained within it, lies the history of distant stars, lost planetary systems, and the powerful forces responsible for sculpting the galaxy itself. Analyzing its composition could reveal chemical signatures not found in native solar system bodies, offering hints about the environments of other star systems. It might even show variations in elemental ratios, isotopic abundances, or mineral structures previously unknown to science. Each discovery would not only answer old questions, but raise new ones about the diversity and complexity of planetary formation across the Milky Way. Precision simulation and pinpointing the object. After identifying consistent anomalies in the data, the quantum AI system did something extraordinary. It moved beyond detection and entered the realm of predictive simulation. Using gravitational data, infrared patterns, and historical orbital anomalies, the AI constructed a detailed model of the object's behavior over time. This wasn't just a rough estimate. It was a high-fidelity simulation designed to track the object's trajectory and narrow down its current location in the vast expanse beyond Neptune. What makes this simulation groundbreaking is its precision. By factoring in micro variations in infrared background noise and the minute gravitational wobbles in nearby Kuiper belt objects, the AI was able to reduce the search area to a 0.3 degrees margin, a tiny slice of sky in astronomical terms. The confidence score? An astonishing 97.2%, far beyond what scientists typically consider necessary to justify a targeted observational campaign. This precise accuracy makes all the difference. For the first time, astronomers now have a data-supported coordinate to target their equipment on, leaving no requirement to search blindly through the outer solar system. Rather than looking for a needle in a haystack, scientists now have a map with an X for the location. Groups are already gearing up to utilize powerful ground and space-based telescopes to monitor the targeted area and verify the predictions of the AI. If verified, this would be one of the most precise and impactful predictions in modern astronomy, proof that the combination of quantum computing and advanced space imaging can deliver discoveries that were previously out of reach. More importantly, it would confirm that we're not just speculating about Planet 9 anymore, we're on the verge of actually seeing it, or whatever this mysterious object truly is, for the first time. The excitement across the scientific community is palpable, with research teams from around the world racing to be the first to capture direct evidence. Scheduled observation windows are being rapidly allocated, focusing an unprecedented amount of telescope time on this pinpointed region. If the predictions hold true, within months, or even weeks, we could finally catch our first glimpse of the hidden giant that has eluded astronomers for generations. The consequences of a successful detection extend far beyond the verification of the object's presence. With optical, and maybe even direct imaging, scientists could initiate immediate spectral analysis, quantifying its makeup, atmosphere, should there be one, temperature, and potential companions such as moons or rings. Each additional data point would either validate or invalidate existing theories, potentially giving rise to a whole new field of planetary science dedicated to studying remote, ultra-cold bodies at the periphery of solar systems. But beyond pinpointing its location, this discovery is already transforming how we think about the solar system itself, ushering in a new era of planetary science driven by quantum insight and cosmic curiosity. The paradigm shift in planetary science. The potential discovery of Planet 9, or whatever this mysterious object turns out to be, marks more than just an astronomical milestone. It represents a paradigm shift in planetary science, challenging long-held assumptions about the structure and stability of our solar system. For decades, scientists believed we had mapped all major planetary bodies orbiting our Sun, but now, with the help of quantum AI and deep space imaging, we're realizing that our own cosmic backyard might be far more complex and dynamic than we imagined. If confirmed, the object would not only extend the boundary of our solar system, but force a re-evaluation of planetary formation models. How could such a massive object exist undetected for so long? Did it form in place, far from the Sun, or was it captured from another star system? Questions like these push the limits of current theories and invite bold new ideas about planet migration, solar system evolution, and even the possibility of interstellar interactions. The discovery also changes the nature of how we practice science. Through the union of observational astronomy with the capabilities of quantum computing, we're embarking on an age where data is no longer the bottleneck. Rather, our capacity to read that data over billions of variables and across years of cosmic motion is advancing at a quickening pace. This blending of fields is creating a new type of exploration, one that employs artificial intelligence not only to analyze, but to predict and simulate the unknown. As algorithms grow more sophisticated, they will help us spot hidden patterns that human intuition alone might miss. This partnership between machine precision and human imagination is opening doors to discoveries we couldn't have dreamed of just a generation ago. In many ways, the search for Planet 9 is becoming a proving ground for the future of scientific discovery itself. Most importantly, this shift widens our perspective. We're no longer just cataloguing planets, we're uncovering the hidden architecture of the solar system, where massive objects may be influencing celestial mechanics from the shadows. It's a reminder that the universe is not static, and that even familiar territories like our solar system can still hold profound secrets waiting to be revealed. The instruments are finally keeping pace with our curiosity, and the findings are redefining what we thought we knew about our place in the universe. Every discovery forces us to confront how much we still have to learn, even about the space closest to home. It challenges the illusion that we have already mapped and mastered our cosmic neighborhood. In reality, we are just beginning to scratch the surface of a much deeper and stranger reality. This newfound understanding also raises fundamental questions about our place in the cosmos. If Planet 9, or any other unseen object, exists on the periphery of our solar system, it challenges the very nature of what it means to be part of a solar system. For centuries, we've defined planetary systems based on observable bodies within certain boundaries. But these findings are a reminder that much of what makes a system is still beyond our sight, waiting at the periphery, shaping the dynamics that we can't quite understand. As we develop techniques for sensing the invisible, the boundaries between what is part of our own solar system and what is outside of it may become less defined, leading us to reconsider the very architecture of space itself. The further we delve, the more intricate and complex the universe is, and that implies the more we know, the more we shall wonder. If this discovery blew your mind, imagine what else is out there waiting to be found. Don't forget to like the video if you enjoyed it, subscribe for more deep space discoveries, and drop a comment below. Do you think Planet 9 is a planet, a black hole, or something even stranger? And if you're ready for more, click the next video on screen where we dive into the star that shouldn't even exist, an ancient object that defies the laws of time itself. Thanks for watching, and keep looking up, because the universe is just getting started.